Welcome back my dear friends and dear students. Very good morning, good afternoon and good evening to all of you. This, as you know, is the DADM, which is Data Analysis and Decision Making number 1 course under the NPTEL MOOC series, and this course, as you know, total number of hours is 30, and which basically gets converted into 60 lectures. Each week we have 5 lectures, each being for half an hour. And my name is Raghunandan Sengupta from the IME department, IIT Kanpur. Now, if you remember that we were discussing about utility theory, the difference, to just give a small recap, utility theory, the different concepts of utility theory. I know that is a double repetition, but please bear with me. We discussed about marginal utility, the u prime, u double prime, the significance of u prime, significance of u double prime, considering that you are risk averse person, risk neutral person and a risk lover person. And based on that, we further proceeded on to find out the concept of absolute risk aversion, relative risk aversion, which is A and R respectively. Then we went to the concept of trying to find out A prime and R prime and how A prime and R prime gives us the properties of the utility function. Then we consider the 4 utility functions, the quadratic, the exponential, logarithmic and the power, and we saw that using those the functional form we could find out u prime, a prime, r prime, and depending on the parameter values, their range, their domains, we could basically see very specifically about risk aversion property using A prime and R prime respectively. Then, and obviously to make things like life things simple, I took a hypothetical example for all these 4 different utility functions and drew them in the Excel sheet, that in the first column you have W, then in the second column you have UW, third and fourth column which were not shown in the Excel sheet in the slide, but still I mentioned time and again, it was basically u prime and u double prime. Based on that, I found out A prime, R prime in the respective columns, and it was basically a double check that considering that hypothetical values of W, based on which you can find out the other sets of functions, they matched with the corresponding theoretical results which we got for A prime and R prime for all the 4 different utility functions. Then further on we considered that given the concept of the utility, I want to find out that how I can classify a human being to be either risk lover, risk hater, risk neutral, and we consider the concept of certainty value. Certainty value was in a sense a deterministic value where the probability was 1, such that the expected value based on the functional form of the utility, you can basically balance, that means the exact value of the certainty value, its corresponding utility would be exactly equal to the expected value of the gamble, the fair gamble, because the probabilities are half and half. And corresponding to W1 and W2, the values which you get, your corresponding values of utility would be UW1 and UW2. I showed that in the last class in a blank PPT slide. I wrote it down and used different colors to make things much clearer. Then I consider that considering we also discussed the last example, which was basically that I want to find out the property of human being, what type of utility function he or she has, and we again considered a simple example where along the x axis you are measuring the values of W and arbitrarily considering 2 values of A and B. We also assumed the utility function was u w is equal to W, such that the expected and it was a fair gamble, even though in the problem I did mention it is P and 1 minus P the corresponding probabilities, but we will consider P and 1 minus P as half and half, which is a fair gamble, tossing a unbiased coin. So, the corresponding expected value for the values of wealth values of A and B, the utilities are u A which is A, u B which is B, hence the expected value would be A plus B divided by 2, And then on the other side of the table we kept a value of certainty C1, if C1 expected value of C1 which will be equal to again u of C1 which is C1 into 1 because 1 is the probability. So, that if it is exactly equal to a plus b by 2, we will say that the person will be indifferent between the gamble and fair gamble and the certainty value. And before and on the graph paper you drew a 45 degrees line. So, hence if it is a fair gamble being balanced by a certainty value exactly. So, the point will fall on the 45 degree line. In case somebody is risk averse, risk lover, then obviously it will mean that the equality sign will be replaced by greater than or less than depending on the way you are trying to analyze risk averse person and risk lover person. So, obviously from that you will get the utility functions as increasing with the increasing trend or increasing with the decreasing trend. The straight line was basically technically increasing at a constant rate. Then further on the last part of the last lecture which was the 47th one, we considered that few hypothetical values are given and you know the utility functional form of that person, but you do not know the parameters. So, you basically keep changing the certainty value at the moment the person basically is indecisive or risk neutral between the gamble and the certainty value. We will know that the expected value for the gamble, fair gamble will exactly match the expected value of certainty value. You could equate them, only unknown would be a in a quadratic form considering the example which we have considered it in an exponential form, and you will basically find out the parameters a and proceed accordingly. So, this was in an essence what we had been covering. So, I will consider further on in the 48th lecture and consider things in much details. Now, the axioms of utility functions for the decision makers would be very important for us to understand. That means, in case say for example, there are two decisions. So, the decision maker would be able to rank them in the sense the utility coming out from A and the utility coming out from B can be either equated in the sense that I am indifferent between the utilities for both the decisions. The second option can be I prefer A with respect to B, hence the utility of A would be better or greater than B, and if I prefer B with respect to A, then I will say that I prefer decision B because the utility of B is better than utility of A. So, in this case if you have so obviously ranking would be very logical and the person would basically be able to analyze A and B two decisions. Now, consider I bring another third decision A, B, C. So, in case say for example, I am saying that the overall utility of A is better than B, that is U A is greater than expected value of U A is greater than expected value of U B, and if the expected value of U B is greater than expected value of U C, then we can always say that the ranking nomenclature would be followed where A would be better than B would be better than C, as it is written in the second bullet point, which means the utility of A is better with respect to utility of B, which is further on better than utility of C. So, that ranking can be done. Now, remember one thing, when I am mentioning the utility, it basically means utility specific, it can change, the ranking can change depending on the utility, but once you have decided on the utility, this ranking concept of A being greater than B, A being better than B, being that better than C would also always prevail. Now, consider there are two decisions. This would not make much sense in the practical aspect, but when we solve the problems, very small problems which we have solved or the assignments which are given, they would be almost on the same line. You will be able to appreciate the essence of utility, expected utility, fair gamble, the concept of certainty value and all these things. So, consider x and y decisions are such that x is equal to y. Then we will assume that means we can combine x with another decision z such that the x will have basically a probability of p. So, that means we are combining x with another decision z and we basically assign some probabilities p and 1 minus p. It could have been basically half and half also, it could have been say for example 0.8 and 0.2 also. So, that does not matter. So, I am taking probabilities of p and 1 minus p. So, on the same lines we have another decision, we take the same decision z with y. So, we are combining x with z and x with y, and such that the probability of y is also equal to p. So, in that case we can say that the probabilities are obviously z is equal to 1 minus p. So, we are combining x and y in some proportions with z and other decisions, and the probabilities remain the same for both the cases. The same means x and z are being combined corresponding the probabilities of p and 1 minus p. Similarly, y and z would be combined corresponding to the probabilities of p and 1 minus p. So, in that case we can say the ranking or the decisions between choosing x plus y and y plus z, x plus z, sorry, x plus z and y plus z would basically be of equivalent value or equal value, because initially we have considered the decisions x and y are same. So, you can consider that there are 3 decisions, 4 decisions, 5 decisions. So, in whichever you combine them, if the corresponding probabilities are same, considering the initial decisions give us the same utility, the ranking would be maintained. Maintain the ranking, I would not use the word ranking, I would say the equivalence between the decisions would continue to be remain the same, provided the following assumptions which I just mentioned would be true, which means one is x is equal to y initially, and the corresponding probabilities of combining z happens in the same proportions. Now, for every gamble there is a certainty equivalent, obviously that would be true, because if it is not a fair gamble, if the wealths or the so called investments are W1 and W2, whatever the units are, they are numbers. So, the corresponding utilities would be UW1 and UW2, whatever the utility, quadratic, logarithmic, exponential, power, it does not matter. So, when we combine and try to find out the expected value, what will we have? We will basically have probability considering for W1 as P1. So, P1 into U of W1 plus P2 into U of W2, where P2 is the probability corresponding to W2, such that the sum of probability of P1 and P2 is 1. So, when we find out the expected value, again I will repeat, it will be P1 into U W1 plus P2 into U W2, that would be equated to the deterministic event. So, consider the fair gamble has a value of C1. So, U of C1 into 1, because the probability is 1, it will be exactly equal to these values which I have taken. So, if I consider U of C1 multiplied by 1, which is the corresponding probability of U of W1 multiplied by P1 plus U of W2 multiplied by 2 P2, such that summation of Pi I is equal to 1 to 2 is equal to 1. So, obviously, in this case this concept of utility would be coming out. So, this is with the certainty value. So, for every gamble there is a certainty equivalent such that the person is indifferent between the gamble which is on the right hand side. This is should not be, I should not highlight this. Oh, my mistake. So, this should be equivalent to the expected on the left hand side, which is the certainty value. So, C1 would be found out corresponding to balancing the or equating the utility coming out from the certainty value and the equivalent and the utility coming out from the fair gamble. So, fair gamble would be the case when, in case this P1 value is half and P2 value is half. So, let us consider the concept of utility, but now it is a quadratic one, and here is the important concept, mainly from the investment point of view or decision sciences. So, comparison between the mean variance of the utility theory. The utility function is a quadratic, which is W minus B W square. So, obviously, B can be any value. Now, consider on the other hand, I am trying to basically find out the returns based on the utilities or return based on the investment which I am making or returns based on the decisions I am making. So, in one hand I am trying to basically find out the returns, in other hand I am trying to find out the so called expected value based on the fact the utility is quadratic. Now, in that case it can be proved in and it can be found in good economics and good game theoretic book or utility analysis book, that for the case when the utility function is quadratic, it is equivalent to the case when we consider the returns to be normally distributed or vice versa. So, this relationship is if and only if. So, if returns, again I will repeat, if the returns are quadratic, my mistake is the utility functions are quadratic, then be rest assured the returns based on which we are trying to do the calculation would be normal, or else if the returns are normal, then be rest assured the utility function based on which we are doing the calculations would be quadratic. This would not be true for other type of distributions. So, based on that we are basically trying to show that without going to the theoretical proofs with a simple example. So, this is the example number 16. So, in the first column we consider the numbers of the investment and the prices, and in the second, third and fourth column we consider the prices of 3 assets, which is A, B, C. The price of A changes from 100, 110, 115, 120, 125, which is in the second column. Similarly, corresponding to third and fourth column, you have the changes for B and C assets, for which the values are 105, 115, 120, 125, 130 respectively for B, and the corresponding values for C would be 80, 90, 95, 105 and 130. Now, based on these values of the prices of the assets A, B, C, we need to find out what is the returns. Now, the returns can be found out in 2 ways. One case can be, I am not going to consider this value, I will just give a simple concept. So, consider your investment in time t1 is equal to at 1 is equal to 1, consider this is 1. So, the suffix would denote the time frame, and the corresponding to that, considering the interest rate is R or capital R. I will come to what is R or capital R within few seconds. And consider the time frame is such that you invest I1 and in the time frame of after one time period. So, this is equal to 1, this is equal to 2. So, this is the time, this is equal to I2. So, in this case if you want to find out R, so I will use a separate color. So, you want to find out R will be equal to I2 minus I1 divided by I1, then you can find out the percentage of this. And in case if you want to find out R, capital R, it will be equal to I2 by I1. So, you can find it out accordingly. So, here the values which are given are for RA, RB and RC, which is basically the value which is given here. It could have been done for small r also, no problem, we would basically get the same result, but I am just trying to make it very specific. Now, based on that, when we want to find out the values of returns for ABC, for A case it will be first value 110 would be 110, 1.1 would be 110 divided by 100, second value would be 115 by 110, third value would be 120 by 115, fourth value would be 125 by 120. So, the corresponding values are obtained for RA. Similarly, when I find out the returns of 115 divided by 105, 120 divided by 115, 125 divided by 120 and 130 divided by 125, you have the returns for B, which is I am just highlighting with the green color. And when I consider the returns for C investment on asset prices, the returns would be capital R would be 90 by 80, 95 by 90, 105 by 95 and 130 by 105. The values are which I highlight by the blue color. And also consider hypothetically the corresponding probabilities based on which the prices occur, which is the second, third and fourth column, the probabilities are 1/5. So, which means for each A, B, C the probabilities are equally dispersed, which is uniform discrete distribution. Now, based on the returns R A, R B, R C, I find out the expected values of returns for A, B, C, which is R bar suffix A, R bar suffix B, R bar suffix C. So, R bar basically means the expected value. So, you find out the expected value for the returns for A, returns for B and returns for C. They come out to be 106, 105, 114. So, these are the returns capital R. So, you could have found out the small returns R also. In that case, the formula, as per the formula, it is basically I 2 minus I 1 divided by I 1. So, you will basically plug in the values and basically solve it. The corresponding value of sigma are given by 0.025, 0.022 and 0.052, and consider that the weights we are considering are as given by, and the weights average are which you want to find out, consider they are 114, 115 and 100. Now, if you want to find out the risk or the interest rate in terms of the total returns, and it has basically less than equal to, it has to be either greater than or less than 0.5 something. So, that is the threshold value. So, you will try to utilize the mean variance theorem. So, mean variance theorem or the concept we will use will be probability of x being less than equal to x, or will be required to find out probability of capital X is greater than equal to small x. So, in both the cases you will use simple concept of standard normal distribution. So, how do you use? I should basically sorry I should erase this, so there is space. So, let me continue. Probability of x minus this E value is basically the expected value of x divided by sigma of x less than equal to x minus expected value of capital X divided by sigma x. This value closes, that bracket closes, and the value basically should be coming out to the probability. So, this technically I will just highlight it, this becomes capital Z, this becomes small z. So, this becomes capital Z and this becomes capital Z and this becomes small z. So, given these values of alpha, given these values of small z, you can find the other values and do your calculations accordingly. So, with the return of 0.5, I basically put in the mean variance theorem, I want to find out it to be greater than. So, what I do is that probability of RB minus the, so this 0.05 is the risk free interest rate, which is there in the bank, such that if you go to the bank invest, you will basically get return which is minimum of this. So, you want to basically analyze your investment with risk based to the risk free interest rate. So, corresponding to B, A and C, the values come out to be about 25, 22.4 and 12.3. So, which means that when you rank them corresponding to that, B would be better than A, would be better than C corresponding to the probabilities which you found out. Now, let us stop here and go back to the utilizing the quadratic utility function, because I mentioned that quadratic utility function and normal distributions based on the returns are equivalent. So, let us take the quadratic utility function W minus B W square with B as 0 minus 0.002, plug them in the values, solve them. So, it would change, but the values were almost the relationship between A, B, C would come out to be the same. So, once you find out the utility of B comes out to be 90.68, which is better than utility of A, which is 88.01, which is still better than utility of C, which is 80. So, if you compare, B is better than A, is better than C, considering the case of quadratic utility functions you are using. Similarly, when you do it the calculation using the normality returns, the values also come out to be the same, which is B is greater than, better than A is better than C. So, you both ways you basically try to verify the fact that the concept of a quadratic utility function and normality distributions are interlinked in general sense. So, consider the following example with two different sets of outcomes. So, they are as follows. The utility function is given by a quadratic utility function w square plus w. I am just taking an arbitrary value and considering there are two scenarios, scenario 1 and scenario 2 or two different tournaments or two different ranking system, whatever it is. The outcomes of the scenarios for the first one are given in the first column starting on 15, 20, 25, 10, 5 and 25, and outcomes for scenario 2 are given by 20, 12, 25, 17, 8 and 30. Now, in the third column I basically write the values of w, arbitrary values. Based on this I can find out uw, which is quadratic one with a certain value of b, and then we can find out the probabilities corresponding to these utilities. So, if I consider say for example, scenario 1 and scenario 2. So, what I will basically try to do is that try to basically find out the relative frequency of the number of events which basically affects scenario 1 and on scenario corresponding to which basically is affected from the situations of scenario 1 and scenario 2, and you want to find out that what is the relative frequency. So, if you find out, so for combined effect being there, combined effect in the sense you want to find out the relative frequency. So, the relative frequency for utility 1.5 with a wealth of 1.5 with a utility of 3.75, the corresponding probability is basically 15 plus 20 divided by 212. Similarly, when I do it for the second, third, fourth and so on and so forth cases of w and uw basically remains continues remain the same as the quadratic utility function. The probabilities for decision 2, decision 3, decision 4, so on and so forth basically combines in the numerator the number of such cases which have been favored for the wealth w, which is 2, and similarly I want to find out what is the number of cases which has been favored under scenario 1 for wealth of 1 point of wealth for 2, and when you compare doing that. So, what you have is basically 15 plus 20, which is basically sum of this. So, this 20 plus 12 is basically sum of this. (25 plus 25 is basically sum of this, and you continue doing it. So, the corresponding probabilities are found out, corresponding utilities are found out, according to that find out the expected value. Now, this diagram basically shows the deterministic and the probabilistic nature of utility. So, in the left hand side you have a not a gamble and a decision tree which is certain probabilities and certain so called outputs with respect to the w's. Obviously, you will convert them into uw. So, and considering there is only one utility function only. So, you will find out the utility here, corresponding to utility here. So, based on that, once you find out the utilities, you multiply the utilities probability here, then this value multiplied by P2. I missed one, I will write it again. This will be U W3. Then based on that I want to basically, so this would green would has come, now it will be blue. P3 U3 this is U3, then I will use another color P4, you see basically U4. So, you want to find out the expected value, what you do is that multiply the utility and the probability. Now, what I am further doing is that in order to find out the equivalence is that I break up that utility of W1 wealth into a fair gamble. So, the fair gamble values I will use the yellow color in for the right hand side. So, if it is yellow, so it basically h 1 into b 1 plus 1 minus h 1 into 0 would basically give me the so called value which is u w 1, because that is equivalent. Next, when I go to the second one which is not shown, second one will basically have a fair gamble with probabilities, say for example, I am considering h 2 and 1 minus h 2, and the values are on the arms are b 2 into 0. So, obviously, in that case the expected value for the gamble would be exactly equal to u w 2. Similarly, for the third case we have, which we will need to find out, it will be u 3 into p 3, which will be equal to the equivalent probability. And finally, if we find out the expected value of h 4 into b 4 plus 1 minus h 4 into 0, the value comes out to be the equivalent terms with respect to the utility u w 4. So, you have to basically understand how you basically place it. So, what we have seen in this diagram, using, even though I used different colors. So, basically we are trying to analyze the expected values of the utilities of the utility functions, which is utility function multiplied by its probability, is being broken down into a case where we want to basically find out the corresponding gamble, even though I am being using this word fair gamble, but it is the gamble. So, technically u w 1 value would be equal to the expected value for the gamble, which is h 1 into b 1 plus 1 minus h 1 into 0, and we will continue considering this for each and every arm. So, with this I will end this lecture and continue more discussions among utilities and what are the different type concepts of other other ideas, how you can basically analyze your decision making will be considered in the further lectures. Thank you very much and have a nice day.